Proxima b, orbiting the closest star to our solar system, has long captivated the imagination of scientists and dreamers alike. While the planet's illuminated side has been the focus of intense study for years, its dark side, permanently locked in shadow, has remained an enigma, hidden from view and speculation. But now, thanks to the remarkable capabilities of the James Webb Space Telescope, the secrets of this mysterious hemisphere are beginning to unfold, offering data that has left researchers both amazed and bewildered. One side of Proxima b is perpetually bathed in sunlight, scorched by radiation and heat, while the other remains frozen in eternal darkness, a place so cold it was assumed to be lifeless and barren. Yet recently declassified images and signals tell a story no one anticipated. The first clues arrived unexpectedly in the form of faint but persistent emissions detected from the dark side of Proxima b, signals that challenge everything we thought we knew about planetary environments. These emissions, particularly in the infrared spectrum, display energy patterns suggesting localized sources of heat and light, phenomena entirely inconsistent with the planet's known surface conditions. This raised the immediate and pressing question: could these emissions be natural, or do they point to something far more extraordinary? The irregularity and apparent structure of the signals have led some experts to entertain the staggering possibility of artificial origins. Could the dark side of Proxima b be harboring advanced technology? If these emissions are indeed artificial, they may be evidence of a civilization thriving under some of the most extreme conditions imaginable. Advanced technology could provide light and heat, allowing life to overcome the challenges of perpetual darkness. Even more astonishing, the patterns of these emissions resemble the kind of organized urban lighting one might observe on Earth, suggesting systematic and deliberate activity. Could it be that an intelligent society has adapted to a harsh, lightless environment, thriving in ways that stretch the limits of human comprehension? The implications of such a discovery are staggering. If life exists here, it may have developed technologies far beyond our imagination, harnessing resources to survive in one of the most extreme environments in the galaxy. Proxima b's tidal locking creates a world of extremes: perpetual daylight on one hemisphere, freezing darkness on the other. On the dark side, temperatures could plummet to levels that make life as we know it impossible without extraordinary adaptations. Without a significant atmosphere to redistribute heat from the sunlit side, any form of habitation would have to rely entirely on artificial energy sources. Could an advanced civilization have solved this challenge, creating systems to transport heat and power into the shadowed realm? Such an achievement would represent an engineering sophistication that surpasses anything on Earth and would offer profound insights into how advanced life might function under radically different conditions. Perhaps one of the most surprising findings was the potential presence of water on the dark side of Proxima b. While surface water is unlikely in such harsh conditions, scientists speculate that insulated subsurface reservoirs could exist, shielded from the brutal environment above. Water is a key to life as we know it, and if it exists here, it raises the possibility of extremophile organisms, life forms specially adapted to thrive under the most hostile circumstances. The discovery of water would not only expand our understanding of planetary habitability, but would also offer a glimpse into how life might adapt to the universe's most extreme environments. Yet despite these groundbreaking revelations, the data leaves researchers with more questions than answers. What is the true source of the emissions? Are they the result of natural phenomena, or do they represent evidence of something far more profound? The regularity of the pattern suggests intent, yet no known natural process can fully explain them. Are we perhaps witnessing the footprints of an advanced civilization? Or is there an unknown cosmic phenomenon at play? As researchers continue to analyze the incoming data, one thing is certain: the dark side of Proxima b is not the lifeless expanse we once believed it to be. Instead, it is a place of mystery, potential, and unprecedented discovery. The presence of emissions from Proxima b's dark side raises another intriguing question: what powers them? In an environment devoid of sunlight, traditional sources of heat like solar power highly unlikely. One leading theory suggests that the planet's core could be geologically active, providing geothermal energy heat that could sustain subsurface reservoirs and potentially power surface systems on the dark side. Another possibility is the use of nuclear energy technology capable of generating immense power in isolated and lightless conditions. If the emissions are artificial, they might represent the workings of a highly advanced civilization that has mastered such an energy source. Whether natural or artificial, the energy source behind these signals could redefine our understanding of power generation in extreme environments. Further analysis of Proxima B's dark side has revealed additional surprises in its thin atmosphere, or rather, what remains of it. Trace amounts of gases including carbon dioxide and methane have been detected, raising provocative questions about their origin. These gases could be the result of ongoing geological activity, or more tantalizingly, they could arise from biological processes. The detection of methane in particular has sparked debate among scientists, as it could be a byproduct of microbial life or perhaps something entirely unknown. The uneven distribution of these gases suggests localized sources, possibly linked to the mysterious emissions, and could provide a critical clue pointing to active processes or even life on Proxima B's dark side. Proxima B is just one of many exoplanets under observation by the James Webb Space Telescope. Yet its dark side stands out as a singular enigma. By comparing Proxima B to other tidally locked worlds, scientists hope to uncover patterns that might explain its unusual properties. While most such planets exhibit extreme temperature gradients between their day and night sides, the emissions and atmospheric anomalies detected on Proxima B's dark side make it a true outlier. These findings suggest that Proxima B may host processes unlike anything we have yet observed elsewhere in the universe. The more we learn about this planet, the more it challenges our assumptions about exoplanets and their potential for habitability. Perhaps the most controversial theory surrounding Proxima B's dark side is the possibility of advanced technology. The structured nature of the emissions and the energy required to sustain them hint at the involvement of an intelligent force. Could these emissions be the work of an extraterrestrial civilization? If so, their technology would be far beyond anything humanity has yet imagined. A civilization capable of thriving under conditions of perpetual darkness, adapting in ways we can scarcely comprehend. While this hypothesis remains purely speculative, it raises profound questions about how life and technology might evolve under conditions vastly different from our own. The discoveries on Proxima B's dark side have sparked renewed interest in interstellar exploration. While sending a spacecraft to the planet remains a monumental challenge, the potential rewards make it a goal worth pursuing. Organizations like Breakthrough Initiatives are already exploring ways to reach Proxima Centauri within a human lifetime, and the data from the James Webb Space Telescope offers a roadmap for future missions. These missions would focus on the dark side, aiming to answer the most pressing questions left by Webb's observations, from the true nature of the emissions to the possibility of hidden structures cloaked in shadow. The dark side of Proxima B is more than just a scientific mystery, it is a mirror reflecting our own questions about existence, survival, and the boundaries of life. If life can thrive in such extreme conditions, what does that say about the resilience of life across the cosmos? The possibility of technology or even life on Proxima B challenges us to rethink our assumptions about what is possible, inspiring hope, curiosity, and perhaps a touch of fear. It reminds us how much we still have to learn about the universe. As we study the dark side of Proxima B, we are reminded that exploration is not just about answering old questions, it is about asking new ones, expanding the frontiers of our understanding. The James Webb Space Telescope has once again demonstrated its unparalleled ability to uncover the unknown, shining light. Ironically, on mysteries hidden in perpetual darkness, the dark side of Proxima B, once thought to be a barren wasteland, now presents questions that challenge our understanding of the universe, Are these findings evidence of natural phenomena, or do they hint at something far more extraordinary, perhaps an advanced civilization thriving under conditions we can barely comprehend? While the answers remain elusive, the possibilities are staggering. The data from Proxima B's dark side inspires scientists and dreamers alike, pushing the boundaries of what we know about habitability, technology, and the resilience of life. It reminds us that even in the vast emptiness of space, there are surprises waiting to be discovered, Dan, that exploration is not just about seeking answers, but also about igniting curiosity and uniting humanity in the pursuit of the unknown. Proxima B's dark side has become a beacon for the next generation of explorers, a reminder that the universe still holds secrets capable of transforming our understanding of existence. Adding to the intrigue, further atmospheric analysis has revealed trace gases such as carbon dioxide and methane in the thin atmosphere over Proxima B's dark side. While CO can arise from volcanic or geological sources, methane is more enigmatic. On Earth, methane is often associated with biological activity, whether from microbial life or more complex organisms, though it can also emerge from non-biological processes. The uneven distribution of these gases, particularly methane, raises the possibility of localized sources, perhaps geothermal vents, maybe microbial colonies, or, in the most astonishing interpretation, the industrial or biological byproducts of an intelligent civilization. If life does exist on Proxima B's dark side, it must be radically different from anything on Earth capable of surviving without sunlight, enduring freezing conditions, and exploiting whatever sparse energy resources are available. One of the most surprising insights from the James Webb data is the potential presence of water on Proxima B's dark side. While surface water would almost certainly be frozen solid, insulated reservoirs beneath the surface heated by internal energy sources could potentially exist. The presence of subsurface water dramatically expands the possibilities for life on Earth. Extremophile organisms thrive in environments once considered uninhabitable near hydrothermal vents at the ocean floor, under Antarctic ice sheets, or within deep rock layers far from sunlight. If Proxima B hosts similar life forms, they might be microbial or even more advanced, having evolved or engineered solutions to the daunting challenges of living in permanent darkness. Such life forms would likely possess biochemical adaptations, unlike anything on Earth, perhaps using chemosynthesis rather than photosynthesis, feeding on chemical gradients rather than sunlight, and building ecosystems powered by the planet's internal heat or artificial energy systems. Despite these tantalizing clues, the data leaves scientists with more questions than answers. The structured emissions hint at intent, but no known natural processes can fully account for their regularity. Are we seeing evidence of artificial constructions, energy grids, or technological infrastructure? Or are we witnessing a cosmic phenomenon entirely new to science, something yet undiscovered that mimics artificial patterns? Researchers are cautious, aware that extraordinary claims require extraordinary evidence, but they are also energized by the implications. The possibility that we are detecting the signatures of an advanced civilization would rank among the most profound discoveries in human history, reshaping our understanding of life, technology, and the cosmic landscape. Proxima b is just one of many exoplanets that the James Webb Space Telescope is studying, but its dark side has become a unique and compelling enigma. Compared to other tidally locked worlds, Proxima b shows anomalies that make it stand out not only in its emissions, but also in its atmospheric behavior and temperature gradients. Most tidally locked planets display stark contrasts between their day and night sides, with thin atmospheres unable to transfer heat efficiently. But Proxima b's dark side shows patterns of heat and gas distribution that resist easy classification. This suggests the presence of active processes possibly involving technology that are moderating the environment in ways we do not yet understand. The most controversial and captivating theory among these findings is the possibility that we are observing the handiwork of an intelligent civilization and extraterrestrial society that has learned to thrive in one of the most extreme environments imaginable. Such a civilization would have to overcome challenges that stretch the imagination, surviving without sunlight, building infrastructures to generate and distribute energy, and possibly maintaining ecosystems independent of stellar input. If they exist, their technologies would be orders of magnitude beyond ours, capable of feats we can only dream of, making them a living testament to the resilience and adaptability of life in the universe. These discoveries have reignited excitement about interstellar exploration, with renewed calls to prioritize missions to Proxima Centauri. Although sending a spacecraft there remains a monumental challenge, organizations like Breakthrough Initiatives are already laying groundwork for interstellar probes, aiming to reach Proxima Centauri within a human lifetime. The James Webb observations provide a critical roadmap for these future missions, pointing towards specific regions of interest: the dark side, its emissions, its atmosphere, and any structures hidden in the eternal night. Each data point adds urgency to the quest, highlighting the profound scientific and philosophical rewards that await us if we can reach this neighboring world. More than just a scientific puzzle, the dark side of Proxima b has become a mirror, reflecting humanity's deepest questions about existence, survival, and the nature of life itself. If life can endure in such extreme conditions, what does that say about the pervasiveness of life across the cosmos? Could intelligence arise under circumstances we once thought impossible?